Happy Wednesday. This is Mrs. Hill. Sorry I won't be here today, but I have you in good hands. Really, all you're going to do today is just write up the data that we've been doing with the photo gates and all that stuff, okay? Remember, our whole big concern is just to figure out what is the relationship between these three things. What we're going to be calculating is acceleration for both of them, okay? On the first experiment, what we changed was the mass of the car. So this is the car mass, okay? And that was the first part that we did before break, okay? Now, the part that we did yesterday, we actually changed the force pulling on the car by changing the mass at the end of the string. So this was from increasing the mass on string, okay? And this was part 2. This is the second part that we did yesterday, okay? So that's kind of a basic overview of kind of what we were doing there. You should already have this first part in the front done here. So you can use this as kind of a guide to help you with part 2, okay? So in order to get to the graph part here, you've got to crunch your data. So what you're going to do is go to your data tables here. Remember I said we're not going to use our calculator today. What I want you to do is get a really good feeling of what an average is. Remember, an average is just the middle of some numbers, okay? So we're just going to do that a little bit. So what I've done here is just add some data. First of all, check the mass of your car. Make sure that you got this correctly. The little car itself was 0.25 kilograms. Oh, I don't know why it's doing that. 0.25 kilograms. So you need to make sure that this first one right here was the one without the bar. The second one was with 1 bar, 2 bars, 3 bars, 4 bars. So if you don't have that, you're going to want to do that. The first thing that we want to do here is when we get an average, don't use your calculator. I just put down the first numbers of somebody who I just picked out of paper, and these were the first couple of numbers. So what I want you to do, if I have a 0.69, 0.69, and a 0.68, my average is in the middle of those. Well, those are pretty tight numbers. So my average is going to be 0.69. Throw it in your calculator, divide those numbers by 3, and you're going to see that it's that. I picked 0.69 because those are right next door to each other, and I had 2 0.69s. With the next one over here, I've got 0.31, 0.32, and 0.30. You look at them right next door to each other, the 0.31 is right in the middle. Okay? So in order to get this number called average velocity, okay, average change in velocity, anytime you see that delta sign, it means a subtraction problem, okay? So my change in velocity is 0.69 minus 0.31. You don't have to write that on your paper. If you feel comfortable doing that, that's okay. But most scientists don't. They'll just take this number, subtract that number, and get their answer. So that's going to be 0.38. Okay? So you would just put 0.38 in that box. This one right here, the numbers are a little bit further apart. I've got a 0.82, 0.82, and a 0.75. I'm going to kind of shy on the upper end, so I might call that a 0.80. You put that in your calculator. That may or may not be true, but it's going to be pretty darn close, okay? Now, this one, again, I've got numbers kind of a little further apart. I got a 0.29, 0.24, 0.21. I know my 0.24 is kind of in the middle. But from 0.29 to 0.24, that's 0.05. From 0.24 to 0.21, that's 0.03. I might take this up to a 0.25 as my average. Okay? So again, my average change in time, my change in time was from 0.80 minus 0.25 equals 0.55. Okay. I'm going to take these two numbers and flip those over here. So it's like acceleration, my change in velocity, remember my change in velocity is 0.38. So I'm going to put 0.38 divided by my change in time was 0.55. Now, I would go ahead and put that calculation in there just so I can follow along with you. And so 0.38 divided by 0.55 is going to be 0.69. Okay? Awesome. Okay? The force, and this is just this one, force equals mass times acceleration. Okay, your acceleration you just determined, it's that one. You're trying to determine the force, so now you need the mass of the car. So the mass of the car up here, for the one that I determined, was 0.25. Okay? So I'm going to take the mass of the car, and remember for this one, it's going to change. So the mass comes from, this is from your data. Okay, so for the one that I just did, force equals, my mass was 0.25 kilograms, okay, times my acceleration was 0.69. We'll give an answer there. Start looking at those, see if, is the force changing, is the force staying the same. Next, what you're going to do is go back to that first sheet that you had. Remember, it looks like this, okay? And then you're going to start putting your data on the back here. I want you to graph your data below as acceleration versus mass, okay? So acceleration is your dependent variable, right? And mass is your independent variable. Make sure you know which axes those go on. I'm going to be checking for that. We ought to know that by now. So you need to graph your data. You're going to have to look at your data tables, graph that up. I'm sure you guys will do great there. You guys have been doing awesome on that. Okay, so remember to use your labels. And then you need to ask yourself, what is the relationship between mass and acceleration? So as mass increases, what happens to the acceleration? Just look at your graph. It'll be able to tell you how to do that. Part 2 is going to be very, very similar, okay? Remember, we didn't get in there and do the independent variable, dependent variable. You guys are great at that. Go ahead and fill that out for us, okay? So you'll find, again, you'll want to do your graph on the back, but this time we've got acceleration versus force applied, okay? So if you look at your data table, remember how we're going to go here. This is part 2 data. Very, very much the same way. What I want to note here is that the mass of your car, okay, what I have for my car itself was 250 grams, okay, which equals 0.25 kilograms. Well, when you added a bar to it, that was adding a 0.25. Let's make that a 5. And I think you added 3 bars to that, right? Well, at least you should have. So if you add all those together, the mass of your car is 1.0. Some of you kind of messed that up, so you're going to want to change that. With this part of the experiment, you should not have changed the mass of your car. If you did, I've got data that you can borrow, okay? Probably should have read the lab a little bit more carefully to pick up on that part of the lab. Okay? So doing this data is going to be really very similar to what you did before. Okay? Then, as you look at this thing, the acceleration, you're going to determine the same way as you did before. This is force. So if you look at these two, this is what we're going to plot remember, this is the independent variable and this is the dependent variable. Make sure you plot those correctly, okay? If it looks like it's a pretty straight line, you're going to want to do a best fit line on those things. Don't ever connect the dots, okay? Just not a great way to do science. What we're doing is pretty, there's room for error, and it's not your fault or my fault or anybody's fault. It's just the way science happens. So we don't want to connect the dots because those are not absolutely true values. Okay? And then you're going to ask yourself, what's the relationship between applied force and acceleration? All that is due at the end of the hour. You're going to want to stay focused. You can help have your partners help you. But hopefully you guys can do pretty much all this on your own. I know you'll do great. Have a good day. I'll see you tomorrow.